So how can we get started writing the equation of this circle that I'm sketching here with center 2, 0 and radius 2? Did we get anything?
Equation for a circle?
In what?
X and Y.
Yeah, in x and y. That we can do it in x and y, and then we know our relationships between x and y and r and theta, and we could figure it out. So, okay, so what would this be using x and y?
Cosine theta.
No, using x and y.
Yeah, relationship.
We're using x and y to write this circle, right?
2 squared.
Was it?
2 squared, which is x squared plus y squared.
Okay, so we got something squared plus something squared equals
R squared.
r squared, which would be
4.
2 squared. Okay, so is it just x squared plus y squared equals 4? No, we need x minus 2, right? We need x minus 2 and then y. So we should all be able to do that, right? It's just the equation of the circle. And so now if we could get this, all we have to do is convert this into as r equals a function of theta. So we could start by multiplying things out. So we got x squared minus 4x plus 4 plus y squared equals 4. And then we notice, look, x squared plus y squared. And we got a 4 and a 4 here, right? So subtract 4 from both sides. And we got x squared plus y squared. What's that?
R squared.
Yeah, so we know that's exactly what r squared is. And then we have minus 4x. What's that? Minus 4.
Cosine theta.
Is x just cosine theta? R cosine theta, right? X is r cosine theta equals 0. Okay, well, notice we have an r in both terms. So we've got r times r minus 4 cosine theta equals 0. Well, so that means r equals 0. What's r equals 0? What's that represent? R equals 0. It's only the pole, right? So that's kind of trivial, right? So it's not going to be that. So then, here we go. R minus 4 cosine theta equals 0 means r, well, we got it. Okay, so now what if so let's graph that and see if it's right. So or we could practice. Let's practice let's graph that in rectangular coordinates and practice making that. So we're thinking that this circle that we started with is r equals 4 cosine theta. So let's confirm that. So we need to graph 4 cosine theta. So here's theta and r. And we want to graph r equals 4 cosine theta. So remember, we're going to talk about things like the max and the min and the period. Okay, so what's the max and min of this? Max and min of this graph? What's negative 4 and 4? Agree? Cosine, the max and min are 1 to negative 1 to 1. So if you multiply by 4, you get negative 4 to 4. All right, how about the period? We should know that that's 2 pi. And we're going to break that period up into 4 pieces. And then we have to know what cosine theta looks like. When theta is 0, does it start at the min, the midline, or the max? Starts at the max. When cosine of 0 is 1, so times 4 is 4. And so then in the first quarter, it's going to go down to the midline. and then down to the min, and then back to the midline, and then up to the max. Okay, so good. So far, so good. So now we're going to graph this, remember, and we're going to think about theta increasing, and what does r do as theta increases? So we can think about theta increasing from, say, 0 to pi over 2. When theta increases from 0 to pi over 2, what does r do? R starts at, when theta is 0, R is 4. Okay? And then what happens? As theta increases, what does R do according to this function? Decreases until we get to pi over 2, and R is 0. So when we get to pi over 2, so imagine your angle increasing. When you get to pi over 2, you're going to be at 0. Okay, so these radial lines are helpful. So like here at, this is like 4, 2, 3, 4, 5. So this is pi over 12. These are I'm going by pi over 12. So at pi over 12, so r is going to decrease as theta increases. So as I go to each radial line, I'm going to have a smaller and smaller value of r. So this, and then like this, this. So each time I move to the next radial line, I have a smaller and smaller value of r. Is it looking like what we were hoping? Yeah. Okay. That circle. It looks like that circle is centered at 2, 0. Okay. Then as r goes from pi over 2 to pi, what does r do? So I'm sorry. As theta goes from pi over 2 to pi, r goes from 0 to -4. So we got to think about the red. So in the second quadrant, since r is going to be negative, we're going to be on the red line, right? We're going to be actually in the fourth quadrant. And it's going to go from 0 to -4. So if you think about the red line, so it's coming out here, so it's going to increase out to this is -4 for theta equals pi. So it's going to be like this. And then coming out, increasing to -4. So we actually get the whole circle just by going from 0 to pi. And then when you go from 3 pi over 2, when you go from pi to 2 pi, it just does it all over again, right? Negative r's in the first quadrant, and then positive r's in the fourth quadrant. So actually, as 4 cosine theta makes one period, it draws the circle twice. So now let's see it in action here. Here it comes, ready? Oops, sorry. So there's pi, and it's drawn it once already. Okay, and so that was the circle that we wanted. Okay, so let's think about that also, that circle radius 3. R equals 3 was that other circle? No, so B equals 3. There we go. So can we find the intersection points of these two circles? So what are the points of intersection of these two circles? How would you do it? So the blue one is r equals 3. And the red one we figured out was 4 cosine theta. So how would you find the intersection points? Yeah, we want to know where is the radius the same, right? So where is the distance from the pole equal to 3? So we would do 3 equals 4 cosine theta. So cosine theta equals 3/4. So we're talking about arc cosine of 3/4. And we know what's the corresponding r value. We know that, right? What is the r value? 3, right? So that was the whole point, that it's on the circle r equals 3. So this is the coordinates of this point are arc cosine 3/4 and 3. So this point we could write in several ways. Okay, so can you come up with 3 different ways to write that point?
The first point that you labeled up there,
Yeah.
should it be 3 arc cosine 3/4?
Oh, r theta. Yeah, sorry. It's kind of it's interesting because when you the functions, the input is theta and the output is r, but when you do the points, you put r first, which is kind of that's why I did that, because I was thinking input and output. So yeah, so it's r theta, but that's just kind of back. So that's output and input r theta. Thank you. Okay, so can you write this point in 3 ways? Can you come up with 3 different ways to write the coordinates of that point? If you can, you understand polar coordinates, all right? So if we know that one is 3 comma arc cosine 3/4, then I want you to write this in 3 different ways. Go.
It would be pi over 2 plus whatever, and then negative.
It's just
That's not the right name. Pi over 2 plus
Plus the
will
arc
put
cosine.
you down
And then
the
the
wrong
negative.
place.
But then the
No.
negative. Oh.
it'll
Or negative.
you add pi. This doesn't split it halfway, right? This isn't this is further towards the top. So if you add pi over 2, you'll be down here and you'll end up here. You see? This isn't symmetric here. You can't just add pi over 2. If you add pi over 2, you're going to be here. Or the other way around. No, it's closer to the bottom. This is closer to here. So if you add pi over 2, you'll be here, and then you'll end up there.
Pretty close.
I don't know.
How do you express this angle?
Could you turn it into the rectangular coordinate?
How do you express this angle right here? So we're struggling with. How do you express this angle right here?
Pi plus cosine.
Pi plus, put you in the third quadrant. Pi plus, put you in the third quadrant.
Pi minus?
You got 1 minute. Okay, let's press on. Here we go. Area. Okay, so we want to talk about area. So how would we find area? So now, instead of area to the x-axis, it would be like area to the pole, right? So you'd have kind of like a wedge. You have r as a function of theta, right here. And then you'd have a starting input and a finishing input, which would create like kind of something of a wedge shape, right? So we want to figure out what that area equals. And so we've got this changing radius here according to theta. So in general, what is that area going to be? So just our general strategy. Area is going to be what? Has anyone learned anything in this course? Yeah.
Is it our fundamental theorem?
Well, but kind of, but it's more saying now we're in polar coordinates, so we have to develop what the area expression is.
The integral of square root.
Okay, so it's going to be integral, an integral of what kind of thing?
1/2.
What's that? We're going to sum up a bunch of radiuses?
No, thetas.
Sum up a bunch of thetas? Summing up thetas?
Outer radius and
If you want an area, you sum up what? Areas. Areas. You're going to sum up areas. If you want charge, you sum up charge. If you want total work, you sum up work. Okay? So this is like a huge theme of the course. So like if you want what? The total amount of work, then you're going to sum up a bunch of little pieces of work. If you want a total amount of volume, then you're going to sum up a bunch of volumes, typical volumes. So our typical area is going to look like this. It's going to be like that. It's going to be that's going to be our dA. Okay, what's the shape of that? What is the shape of that thing, generally? Triangle, right? So if the angle is small enough, d theta, right? If it's small enough, then we can think of that just as a little segment, and we got a triangle. So dA is going to be 1/2 base times height. And so this is going to be the base right here, and then the height will be this distance out here. So from here out to here is the height. And we're going to do 1/2 base times height. So let's do the height first. What is the distance from the pole out to our function? With confidence, I like it. R. And now, what is the base? Okay.
D theta.
All right, so d theta. So the thing about theta is an angle, what, gets further apart as you go further away. So we need to use the, what, arc length formula. Arc length formula to approximate that little segment. So if you have an amount of an angle, which is d theta, so this is opening, our opening is d theta, and we are r away from the pole, then what is that little arc length right there?
Or 1 minus dr d theta squared d theta.
No, that's a little too complicated. So like, just think about arc length on a circle, right? So S equals what?
R squared plus Y squared.
No. Remember what the arc length is in a circle? If that's radians, that's what radians is, number of radius lengths, right? Theta is number of radius lengths. So how do you calculate S?
Theta over.
No, it's r theta. Okay, so theta is the number of radius lengths, and r is the length of one radius, so the length of S is the number of radius lengths times the length of the radius. Okay, so what's that for B then? Our angle is d theta, and our radius is r. So it's going to be r d theta. So that's B. So I'll throw the d theta over here. So our dA is 1/2 r squared d theta. That's what? That's the area of a sliver that we're using the triangle formula for. And we're going to add all those slivers up from theta 1 to theta 2. Triangular slivers of area. So our area is going to equal integral from theta 1 to theta 2, 1/2. And then what is r? R is our function of theta, right? So r is a function of theta. So it's our f theta function squared, which is r squared d theta. Questions on that? Does it make sense? So again, we're summing up a bunch of these triangular slivers as theta increases from theta 1 to theta 2. So each one of those is area of a triangle. The height of the triangle is just the radius. The base of the triangle is this little arc length right here, which is just distance times angle, r d theta. So we get 1/2 r d theta times r, or r squared, 1/2 r squared d theta. There it is. And that's, we know that r is a function of theta. Okay, so let's go back to that last example that we had there. What did we have? 4 cosine theta. And r equals 3. So with that formula, we could find things like, what's the area of this moon right here? So you want to use rectangular coordinates to find that? Not very convenient, right? So using polar coordinates to get the area of that moon, this is a lot more convenient. Okay, so we're going to set up our integral. Okay, so area is theta 1, theta 2, 1/2 f theta squared d theta. All right, what's theta 1 and theta 2? What's theta 1? So where are we integrating from what angle to what angle?
3.
0? Angle theta equals 0 is right here. We could do that and then, yeah, and double it, because so, you know, we're just doing an area, we know that's symmetric. So we could go from 0 to, and then we're going to 2 times. Zero to what?
R cosine 3/4.
R cosine of 3/4. Of 1/2. Okay, well, what function are we integrating to get the area?
4 cosine theta minus 3.
Okay, so if we did 4 cosine theta, would it be finding the area of this moon? And if not, what area would it be finding? If we did just looked at the 4 cosine theta graph and integrated from 0 to r cosine 3/4, can you see what area you would get? Would it be just this moon shape?
No.
Would it be more or less than that? It'd be more. It would be, this would be the boundary here, 0, and then you have this boundary here, and it would be then all of this. Because it doesn't know that this boundary is here. All right, and then if we just did 3, it would be what? All of this. If we did the function r equals 3. So really, we've got the situation where we want this area between these two curves, right? Between these two curves, we've got the outer curve and the inner curve. So to get the area between, yeah, we're going to subtract. We're going to go outer minus inner. So the outer is, so let's just do it as 2 integrals, okay? We'll just do it as 2 integrals. So 0 to r cosine 3/4 of that. We know that will be this whole wedge here. And then we want to subtract 2 times. One half. And now what's our r function now? 3 squared d theta. So whenever you do these areas between polar curves, it's going to be outer area minus inner. Right? If we just did that first integral, it would be all of this area. So ignore the blue curve. It would be this whole wedge like this. From there, from 0 to there, and all of this in here. And then we times 2, and we get it all that. Right? Then we're subtracting off what's inside the blue, which would be the function as r equals 3.
So you can't do it like we did with the rectangular coordinates where we subtract the functions in a single
Yeah, you could do it in a single interval. You just gotta make sure you're not gonna put it inside the square, right? You can do that minus that. So the danger is don't do 4 cosine minus 3 quantity squared. So yes, you could have that whole thing minus that whole thing. And that works, yeah. Okay, does it make sense? And then it'll be multiplying by 2 gives us 2 times that thing there. Okay, how do we do this integral here? Let's do the top integral just as a refresher, because that's an important one. So we got the 2, and the 2 goes away. 2 and 1/2 goes away, right? So we got 0 to r cosine 3/4 of 16 cosine squared. This is the most important integral from whatever section that is. 6.2. Either cosine squared or sine squared. Everyone needs to know how to do that integral by hand. Do you remember? What do you use? Half angle formula. Half angle formula. So it's (16 times 1/2) 1 plus cosine 2 theta. And if it's sine squared, 1/2 1 minus cosine 2 theta. And then you're home free. So that's just the first one, and then you're going to subtract that one, which is really easy, right? That's a really easy integral. Just 9 d theta. So it's that minus that. I'll just write it again. And we got the area of the moon, right? That will give us the area of that moon shape. Are we good? Do you follow? Okay, so let's look at some from the sheet. There's probably more than you want to do for practice. So let's pick some off from the sheet that I posted. Questions on this? Okay, so 1 and -3. So our max is going to be 1, and our min is going to be -3. So what's our midline? -1. So, okay, period. So if it's sine of 3 theta, what is the period? So we need to get the period, we need 3 theta to reach the period of sine, which is 2 pi. So the period of sine is 2 pi, so you just set that thing equal to 2 pi. And then we're saying what value of theta would make 3 theta be 2 pi? 2 pi over 3. So where is that? We need to zoom in here. Okay, so 2 pi over 3 is right here. So now we need to split that up into 4 pieces. Half of it's pi over 3. So the period is 2 pi over 3. And we're splitting it up into 4 pieces. And then where's this going to start? The mid, the midline, or the max? It's a sine graph. Midline, -1. So it's going to be at -1, it's going to be at the midline. In 1/4 period, what does sine do? Does it go up or down? Go up to the max. And then halfway, back to the midline. Down to the min. Back to the midline. Okay, and then it's going to repeat it again until, and it'll get another full period at 4 pi over 3, which is, so 1, 2, here. So the first period is at 2 pi over 3, and the second period at 4 pi over 3. Why is that graphing that? Okay, let's give it a shot, okay? If we can do this one, we can do any one, right? This is hard. Let's do it. So at 0, where are we? At 0, what R value are we at? When R equals 0, so this is our R, and this is our theta. At R equals 0, we are at? Negative 1. So here, R equals 0, or theta equals 0, sorry. I got this backwards. Theta is this one, and this is R. Okay, so at theta equals 0, or at R equals negative 1. Boom, right there. Okay, and so then we're going to go just to pi over 6, and when we go to pi over 6, what's going to happen? It's going to go from negative 1 to what? Positive 1, and somewhere in between it's going to go through the pole, because R equals 0. Do you see that? So let's break this up into 6, 12 steps. Why isn't it doing it? What happened to my line? There it is. Oh, it just disappeared. Oh, that is pi over 6, right. These are because these are pi over 12s. Okay, so I already have that. So this is pi over 6 right here, and by the time it gets to pi over 6, it's at 1. All right, so we can graph that right there. And in between, what's it going to do? It's going to decrease to 0, something like this. So it's going to get less and less to 0, and then increase to 1. So that's just this first part here, right? So R starts at negative 1, and at pi over 6, it's gotten to positive 1. So in between there, it goes through the pole where R is 0, right there. Okay? Then it goes what? Back to negative 1 by the time it gets to pi over 3. So here's pi over 3. It's going to be back to negative 1 the same way it got there, by decreasing through 0 to negative 1. So it's going to be like this. Oh, I messed up. Shoot. I'm going to go through the pole. That. Okay, and then it's going to go in the next pi over 3, which is pi over 2. This is pi over 2 right here. It's going to make it down to negative 3. So we're going from pi over 3 to pi over 2, but we're going, and then R goes from negative 1 to negative 3. So we're our angle right now is pi over 2. Our R is negative 3. This really is awesome exercise for understanding how polar coordinates work, if you can put these together. Okay? Then in the next pi over 3, it's going to go from negative 3 to negative 1. So when it gets to this angle right here, it's going to be at negative 1, which is right here. It's kind of symmetric to what it did before. And then it's going to go to positive 1. It's going to go through and it's going to go to positive 1 right here through the pole. Because there's this R equals 0 in there. Shoot, did I blow it? And then at pi, it's back to -1. Which is pi is this way, -1 would be here. Okay, and then it's going to do that whole thing again, but it's going to be all now symmetric about the x-axis up top. So it's going to do this and come back and go up here, and then around back like this. So let's just stop there. We'll have the computer do it from here. But did you catch it? Were you able to follow that? So the next one we'll do will be a little easier. Okay. So let's put this in the computer and see how we did. So f of theta equals, what was this? 2
sin 3 theta minus 1.
Ready? We need more theta though. Oh, what happened? Where's the rest of it? It's only showing that first little part. Why is that? Oh, because I didn't do n. Okay. So here we go. I'll just put it side by side there. So now we got to increase n. Ready? Here we go. And down there, and then back up like that. And that's as much as we got. So yeah, we got a good start on it. We still had three more periods to go to finish it. So this was just from the first period that we were able to get that much, and then you have to do three times as much as that to get the whole thing. Okay, so let's try an easier one. That was pretty challenging. So let's do this one right here. The graph is already given. So I'm going to give you some pi. Okay? Now, from pi to 3 pi over 2, so we're thinking this is the third quadrant. First it's going to decrease to 0. And so that was going to look like what? It's going to decrease to 0 at first. And then through here, it's going to go to, at 3 pi over 2, it's going to be at -1. So 3 pi over 2, where's -1? Here. That. And then in the fourth quadrant, we're starting at -1, and as the angle increases, we're going to go back through 0, and then when we get to 2 pi, it's going to be back at 1. So first it's going to go from -1 to 0, and then increase positively out to 1. So it's this. Loop with a little loop in the inner loop. What's that? Sand dollar. Okay, so can we look at this graph and figure out what f of theta is? What's our period? First of all, is it a sine or cosine? Sine. What's the period? 2 pi, that's nice, so it just is going to be sine theta. And then, how about our max and min? Oh, is it? No, it was a little different. Okay, the midline is moved up 1. And then this thing is stretched how much?
Twice as much.
twice as much. So that's actually what we just worked on. We just worked on 2 sine theta plus 1. That's what that red curve is. And that's what that looks like in the polar plane. So let's graph it on my grapher and make a pretty one. Questions on making that? So that's very fair game, be able to do that. And the reason I like these problems so much is it forces you to understand polar coordinates really well. So that's why I like these problems, because you are forced to really understand what's going on in the polar plane, especially with negative r, okay, with negative r's and how r changes with theta, okay? So, question? Yeah?
I didn't get the sketch in the middle, like -1.
So 3 pi over 2 to pi, this quadrant here?
And I mean in the middle of the low line.
So which angle, for which angles? From where? So first quadrant was this here. Second quadrant was this part here.
Yeah, and
The
then
third quadrant was this. That one?
the third one.
Third quadrant. So the angle goes for, we're talking about pi to 3 pi over 2. So from here to here. At pi, we're at 1. And what happens to the, so we're at 1, and then when we get to 3 pi over 2, we're at what?
Negative.
-1. So at 3 pi over 2, which is this angle right here, where is -1?
Down there.
No, -1 is here. For this angle, 3 pi over 2, -1 is up here. Do you see that? This is the opposite direction of 3 pi over 2. So what happens is it decreases to, r decreases to 0, and then keeps decreasing to -1. So here's, see, r is getting less and less and less to 0. So you got to imagine that angle sweeping this way. R is getting less and less to 0. That's right here. And then it's going to keep getting less to -1. So now the angle keeps turning this way, and now we're going from 0 to -1. Does that help?
Yeah.
Okay, let's do a pretty one on the grapher here. So it was 2 cosine theta plus 1?
2 sine.
2 sine theta plus 1. 2 sine theta plus 1. Okay, here we go. So there's our first quadrant, and then our second quadrant, and then our third quadrant makes that loop to there, and then there it is. Okay, so we want to find the area of the loop. What's the area inside the loop? How are we going to do it? I want to find the area of that little thing right there.
Can you do the integral of the polar coordinate?
Yeah, we're going to do polar coordinates, so it's going to be, what's our area function? It's going to be 1/2, right? 2 sine theta plus 1 squared d theta. Right, that's our 1/2 f theta squared d theta. Question is, from what to what?
Pi to 2 pi.
Pi to 2 pi. What do you think? Pi to 2 pi going to get us that? What defines where we're going to start, what angle we're going to start at, and what angle we're going to finish at? Go ahead.
Oh, it would be the reverse of that, so 2 pi to pi.
2 pi to pi?
Because if you get pi to 2 pi, it should give you the outer, or like, what's inside of minus.
Okay. But we just want the area of the loop, so it really just concerns that part of the curve. It doesn't concern all this other stuff, right? Like all this other stuff here doesn't really make a difference. So how are we going to determine what those are?
0 to pi over 2.
0 to pi over 2 would give us all this area here. That would give us all this area here. 0 to pi over 2, give you all this area here.
P when be the angle measure when it crosses the pole.
Yeah, so we want to start when we cross the pole, and we want to end when we cross the pole again. So what's true about those places?
The function is 0.
Yeah, we want to know where r equals 0, right? We want to know where r equals 0. So we got 2 sine theta plus 1 equals 0. So sine theta equals negative half. Who remembers their trig? Angles are. So we got a third quadrant angle and a fourth quadrant angle. Negative half. It's going to be 7 pi over 6 and 11 pi over 6. Okay, so we're going to integrate from 7 pi over 6 to 11 pi over 6 of 1/2. Okay, and this would be 4 sine, I'm going to multiply this out, 4 sine squared theta plus 4 sine theta plus 1 d theta. If we were doing this by hand, how would you do 4 sine squared theta? Half angle formula. 4 sine theta is easy, plus 1 is easy. So let's put it in and see what there is. I'm going to just use technology now. It's going to be I. So what do we say? From 7 pi over 6 to 11 pi over 6, 1/2. 2 sine theta plus 1 squared d theta. We got 0.546. So if we, just to see if that's right, imagine 1 square unit here. 1 square unit would be 1 by 1 square. Would we buy that our area is a little bit more than half of that? Does that seem reasonable? So there's 1 square unit, 1 by 1, right? It's saying that the area of that thing, according to the way we set up the calculation, is a little more than half of that square unit. Does it seem reasonable? Yeah, it seems reasonable. That a little more than half of that. Okay, questions on that example? Let's do another one. This one is 0, so we're gonna, it's gonna decrease to 0, and then keep decreasing to -3 by the time it gets to pi over 4, so something like that. And then at pi, now we're at pi over 4, which is actually this angle, but we're at -3, right? So then as you go to pi over 2, it's going to go from -3 to 0 to 3. So by the time we get up at pi over 2, it's going to be 3. And then again, as we go from 0 to 3 pi over 4, it's going to go from 3 to -3. So here's 3 pi over 4, -3 is here. So it's going to go that. And then by the time we get to, so then we go from 3 pi over 4, where it's at -3, to pi, where it's at 3. So at pi, it's at 3. Half done. Half done. So now from pi, it's going to go again from 3 to -3 by the time it gets to 5 pi over 4, which is here. So we got another one of these. And then at 5 pi over 4, here's 5 pi over 4. We're at negative 3. And then by the time it gets to 3 halves, we're going to be back at positive 3, which is here. And then we're going to go to 7 pi over 4. It's going to go from 3 to negative 3, which is here. All right, and then finally, at 7 pi over 4, here, it's at negative 3, and it's going to go through 0, and at 2 pi, we're going to reach positive 3, and then we're done. Now, they shouldn't, well, we'll take a look at the actual one, but the petals don't cross. None of these cross, okay? There's no crossing except at the pole. Let's see that in the graphic. Any questions on that? Question? All right, let's see it on my thing here. What was it? 3 cosine 4 theta or 2 theta? 4 theta? Right, because the period is 1/4 as long. Here goes. So there's to pi, and then the second half. So notice they don't cross except for at the pole. Okay, find the area. So this is for your sheet now. Find the area of one petal. Find the area of one petal for your sheet. Set up an integral that represents one petal. Set up an integral that represents the area of one petal. Let's see.
Are we only setting up the integral, or?
Yeah, just set up the integral. It's fine. And then your last task is this. So the integral to find that shaded area.
Do we just set the angles or?
You have to set them up. Set them up. So area of one petal, and then the area of that shaded region. So what do you
Yeah, it doesn't.
Four theta equals our cosine of 0.
Yeah.
4 theta equals our cosine of 0.
Whatever you start. Oh, this new to that and this will change that. Because he said just find the area of one. Because he has this is right. This one was a staple. You should do that.
But you can also set that up to find a specific purpose. So you have a generic one.
Yeah. The flow line is the what? The flow line? The flow circle. Is that in a way?
Yeah.
You have your same constraints here. Your area is equal. Right, that's why I said I find one times that. Because now with yours, I mean, you might be able to solve that by one, you might go have every single one of them. I place to work. I just want for a specific pedal instead of generic. Sometimes if you find where it crosses, these are the changes.
Yeah. Oh, it should be one. Yeah. So for data.
Pi over 8. 3 pi over 8. 5 pi over 8.
Oh, sorry.
Okay, so did you see what I did? So basically we want to find it where these pedals stop and start. We want where that function the rate is 0, right? Which is the same as saying where is cosine equal to 0. So then we need what angles make cosine 0. Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. But that's equal to 4 theta. So these different, wherever it crosses the pole, that's at pi over, I'm dividing each one of these by 4. So this first angle that it crosses the pole is at, that's pi over 8. And then it comes back around and it crosses the pole right there, that's 3 pi over 8. And then when it comes back to here, that's 5 pi over 8. So this pedal right here, we want to use that pedal right there, that'd be theta from 3 pi over 8 to 5 pi over 8. Did you catch it? So now these intersection points. So I could do this one or I could do this one. It's whatever. What's that?
Oh, sorry.
Oh, okay. All right. So now what about these intersections? Well, now you're saying 1.5 equals 3 cosine 4 theta. So we're saying where is cosine equal to? 1/2. Who knows their trig? Okay, 1/2 would be, right, pi over 3. Does it strictly have to be? We're saying plus or minus 1/2?
Did you divide 1/2 by 3?
Yeah, because this is crossing through, okay, so this circle is crossing through where r is 3 and negative, or r is 1.5 and negative 1.5, right? Because we were in negative territory half the time. So every time this thing crosses, it was crossing, say, here's crossing, that's positive 1.5, but then that's negative 1.5. And there's another negative 1.5, and then there's a positive 1.5, and then there's positive. So we need, for both plus and minus, r equals 0.5 to get all the angles. So it's going to be pi over 3, 2 pi over 3, 4 pi over 3, what's next? 5 pi over 3, etc. But then divided by 4. So theta is pi over 12. That's this one right here. That's pi over 12. And then 2 pi over 12 would be pi over 6. That's this one right here. That's 2 pi over 6 right there, the angle. Just a pi over 6, okay? And then pi over 3 would be back around this way. There's pi over 3. And then there's 5 pi over 3. And then divided by 4, right? So 5 pi over 12. Maybe this wasn't right. Pi over 3, 2 pi over 3, 4 pi over 3. No, that's right. 5 pi over 12? Yeah. So this is pi over 3. And that's 5 pi over 12. Not right. Not right.
In the very first setup, when you said 3 cosine of 4 theta is equal to 1 1/2, and then you made cosine 4 theta if it's still equal to 1 1/2 or 1/2. Shouldn't you have divided it by 3 to make it 1/6? In your second step.
Pi over 12. 2 pi over 12 is pi over 6. What? Say it again?
So we want to find where 3 cosine 4 theta equals. Never mind.
Yeah, I got it.
Yeah, so
So pi over 12, pi over 6, pi over 3, 5 pi over 12. Okay, so pi over 12, pi over 6, pi over 3, 5 pi over 12. So what's the next one? Seven pi over 3. Which would be 7 pi over 12. So this is 5 pi over 12, and that's 7 pi over 12 for those angles, where that starts. So that's easier. This one's later on. So this is the same area. So let's do this one because these are angles. 5 pi over 12 to 7 pi over 12. And it's going to be outer minus inner. So you're going to have the outer 1 1/2 f of theta squared, which is the 3 cosine 4 theta, minus 1 1/2 1.5 squared. There it is. Okay, we got to run. So I'll definitely have off stars tomorrow. We'll do 2 to 4, okay? 2 to 4 off stars for study session for the exam. And in the next couple hours, I'll finish up posting exam review materials, okay?
On the exam, how many applications for physics?
Well, probably just one. Because there's a lot of stuff we covered.
How long of all it?
Probably just one of everything, right? There's so much we covered. It's just one of everything. So, yeah, everything's important. In terms of the old stuff, okay? So